So this is the cascade activation of pancreatic zymogens within the lumen of the small intestine. Okay, so, right, this is this vagus innervation, the vagus nerve. This is cholecystokinin. So these two things, right, so here's the intestinal epithelial endocrine cell. These messages go to the pancreatic acinar cell. The pancreatic acinar cell then releases the zymogens into the intestine. Those are the precursors, right? And here we've got trypsinogen, chymotrypsinogen, proteolastase, and all these other ones that we listed. Okay, when trypsinogen gets released into the lumen of the small intestine, which is what this cylinder is supposed to be, an enteropeptidase cleaves trypsinogen into trypsin. Trypsin is the active form of the enzyme. Trypsin can activate a couple of different ways, right? So trypsin can do its own work, or trypsin can come down here and activate these other pre-active enzymes. So you've got chymotrypsinogen, and then it gets cleaved to chymotrypsin. Proteolastase gets cleaved to elastase. Procarboxypeptidase A gets cleaved to carboxypeptidase A, and procarboxypeptidase B gets cleaved to carboxypeptidase B. So, one more time. Okay, you have the intestinal epithelial endocrine cell. That's a little different than our enterocyte, but our enterocytes can also act as sending hormones as well. An endocrine cell sends a messenger directly into the bloodstream. So, it releases cholecystokinin, or the vagus nerve can also tell the pancreatic acinar cell, to release zymogens. And remember, our zymogens are our pre-active enzymes held in those vesicles inside the exocrine pancreas, right? So go ahead.
I'm sorry.
No,
Can you start again with the intestinal epithelial endocrine cell releases the CCK into what?
So into the bloodstream, like
into
an
the bloodstream,
and then it goes to the pancreas.
Okay.
And same thing, the vagus nerve releases the signal, the nervous signal, directly to the pancreas. So one way or the other, or usually both, that and exocrine pancreas gets the signal that it needs to release the pre-active enzymes because there's something to digest. Mm-hmm. So it releases all these zymogens into the lumen of the small intestine via the pancreatic duct. Trypsinogen, chymotrypsinogen, proteolastase, procarboxypeptidase A and B. Okay, so in the duodenal enterocyte, we've got these enteropeptidases, right, sitting up on the top. So these run into the enteropeptidase, and trypsinogen becomes trypsin. Once it becomes trypsin, it can activate all of these other ones. So trypsin activates all these other precursors to become active enzymes so that digestion of proteins can happen in specific locations. So let's go back to the outline.